Okay. So I'm not going to revisit it, but on the previous slide or slides, we talked about cold clouds, and cold clouds to me are just clouds that you get snow forming. And starts with the letter B, I called it the Bergeron process, right? Snowflakes forming. And then we talked about actually, depending upon the temperature profile, you can get from snow, like starts out as snow, you can actually get rain, okay? We also talked about freezing rain and sleet. You get by what we call a temperature inversion, kind of a warm pocket or cold pocket being stuck in between, okay? So that was all that. Now, warm clouds are not quite so complicated, okay? So warm clouds, of course, it's going to fall as rain, okay? Warm clouds is going to fall as rain. But you'd be surprised in the spring and the fall right now, like when we get rain today, good chance that it started out as snow. I just think that is so cool. Okay, so within warm clouds, what do we have going on? Well, it's not the Bergeron process. Actually, it's called the collision coalescence process. So if I'm looking for a vocab word to put on your test, that's probably a good one, collision coalescence. So basically, well, did anybody ever tell you not to eat snow because it's dirty? All snow is dirty. Well, actually, all precipitation is kind of dirty, snow and rain, because it actually, the liquid actually joins around something called a cloud condensation nuclei. Cloud condensation nuclei, or CCN, are actually dirt is a great cloud condensation nuclei. It's just something to kind of get the party started. A piece of dirt in the atmosphere basically says, all right, water, you're going to go ahead and go from a vapor into a liquid. You're going to condense. Okay, it kind of gets the party started. And that happens with the Bergeron process too, and the collision coalescence process. So then I just kind of have a series of slides here. The collision coalescence part is that basically large drops collide with smaller drops. Okay, so we have a big collector drop. That one's kind of bigger than everything else. Okay, so basically that one, as it falls through the cloud, gravity's going to take hold, and as it falls, it's basically going to collide into smaller pieces. So kind of from left to right, you see this one kind of gobbling up the little pieces underneath it, okay? And this one gobbling up the little pieces underneath it. So the larger one is affected by gravity more than the smaller ones. Now, I don't know how much I'm going to talk about this semester, but all clouds actually, the reason that all of that liquid doesn't come crashing down is because actually there's kind of a gentle, what we call updraft. Literally there's like a wind that kind of blows straight up, okay, that kind of keeps those liquid particles from falling down. If you've ever walked through mist or walked through fog, you actually can look closely and you'll see like little tiny little drops kind of falling. I think that is so cool. So you're walking through a cloud in essence. So collision coalescence makes those raindrops large enough to basically gravity then says, hey, you're out of here. Your gravity takes hold and wins out. So one of the things about collector drops is they can sometimes go ahead and break into smaller collector drops. So here we have this collector drop that's been kind of traveling through. The more massive it comes, the faster it goes. Basically what can happen, I've seen animations of this before, it gets to kind of flopping, okay, and then it breaks into more collector drops. So that's kind of the dynamics we have up in warm clouds. Okay. So I think the next slides, I'm just going to talk about cloud types. And here in a minute, we're going to talk about them, and then we're going to go ahead and get up and go outside and look at clouds, because I think we've got a few cloud types right now. So I don't know if you knew this, but I guess Walt Disney, when he went to go make his characters, his cartoon characters, he actually looked at clouds and came up with ideas in clouds to make his cartoon characters. You've appreciated clouds before. They kind of come in different shapes and different sizes and all that. But I'm going to give you 10 names, all right? And the names actually are based upon two ideas about the cloud. One is the cloud flat or is it puffy? Okay, if it's flat, actually we're going to have the word stratus somewhere in its name. And if it's fluffy, we're going to have the word cumulo somewhere in its name. The other thing, and this is kind of hard to gauge, is does the cloud look like it's kind of close to the earth? Okay, actually if it's kind of close to the earth, that's a low cloud, and we're not going to give it an extra prefix. And we kind of break the atmosphere up into kind of three sections for clouds. We have the close clouds, we have the middle clouds, And if it looks like it's a middle cloud, then we're actually going to use the word alto. And then we have the high clouds, and we're going to use the word cirro or cirrus. So we're going to kind of mix and match the stratus or strato and cumulo with, you know, flat or fluffy, and with kind of what elevation it is. I guess one more thing is it raining? Is it precipitating? Is it dumping on us? And of the 10 cloud types, we're going to see that there's a flat sort of cloud that dumps on us. We're going to call that nimbostratus. Okay? Get us, nimbo means raining, stratus means flat. And then there's a fluffy sort of cloud that dumps on us. Those are our thunderstorms. Okay? The fluffy, if you think back, and again, we might get some thunderstorm, severe weather this afternoon. Okay, those are going to be fluffy clouds, and they're raining. So we call those cumulonimbus. Okay, so it kind of has the NIMB thing in it. So 10 cloud types. All right, so I have some pictures of the 10 cloud types. So this is not a photograph, this is a figure to kind of show you the 10 cloud types. And let's see if we can kind of see what I was talking about. First, over here on the left, you can see the low clouds. Okay, here's kind of low clouds. Here's middle clouds. Okay, and here's high clouds at the top there. Okay, and look for our flat ones. So we have just plain old stratus, okay? Then we have alto stratus, okay, and then we have cirrostratus. Okay, alto and cirro mean middle and high. Okay, then we have the fluffy ones. We have the cumulus, kind of the low cumulus, and then we have the middle cumulus. Okay, and then we call middle cumulus are called alto cumulus. And then we have the high cumulus called, cirrocumulus. Now, I'm gonna next to cumulus, I'm gonna say the size of your fist. So in here in a minute, and I hope it's not all clouded over when we go out there. But if you hold up your hand, kind of extend it, and the cloud is about, the fluffy cloud is about the size of your fist, then that means you are looking at a cumulus cloud. Okay? If you extend your arm, and it's about the size of your thumb, then it's probably farther away. So it is actually an alto cumulus. So I'll put thumb there. And if you extend your hand, and it takes your pinky, only your pinky, to cover up that cloud, it's probably a high cloud. So this is your pinky. When was the last time you wrote the word pinky? Okay. So those are ways of kind of telling those sort of clouds. Let's see. What else do we have? Now, actually, there's another high cloud up there. If it's high, then we're going to go with some sort of the word cirro or Syria, you know what I mean. So there's just kind of these high wispy clouds. They're flat. They're the highest clouds called cirrus, seriously. Then I guess we just need to address our raining clouds, okay? So raining clouds get the prefix nim, N-I-M-B, or nimbo or nimbus or something like that. So nimbostratus, stratus means flat, and nimbo means raining. Nimbostratus. Now if you're like me, we're going to look at the other rain cloud and we switch the terms around. So we have nimbostratus, but here is our thunderstorm cloud. Of course, our thunderstorm cloud is puffy, so we're going to go with cumulo, okay? And we're going to have to use some sort of nimbus, okay? So actually, it's cumulonimbus, okay, is that one. So those are the 10 cloud types. Pretty cool. One other thing I learned, actually, I'm going to pick on the stratus clouds. Okay, I'm going to pick on the high stratus cloud up there. The cirrostratus. So cirro means high, stratus means layered. Those are the ones that give you some really kind of cool optical effects. Like if you see something neat around the sun, you can still see the sun because they're kind of wispy. They're not very thick. Okay, but if you see something like a sundog, I think I showed you a picture of that the other day, or if you see something like a halo. Halos are basically kind of a ring around the sun. Good chance that cirrocumulus have given that to you. I've heard this, the altostratus, alto meaning middle, stratus meaning flat. Altostratus, if the sun or the moon is hiding behind the altostratus clouds, it'll just kind of take the disk of the sun and kind of water it out a little bit. So it'll kind of make it look watery. I heard that description for an altostratus cloud. I'm like, really? But it's true. Next time you kind of see a wispy cloud in front of the sun, you know, you can still see the disk of the sun. It's just kind of watery. So it makes the sun look watery. All right, so now some photographs. The photographs don't really do them justice because I kind of mentioned the fluffy clouds. Like this is cirrocumulus, and actually this is both cirrus and cirrocumulus in the same photograph. You're like, is that possible? Yeah, definitely we can have a mixture of clouds up there. It's hard to really tell. Is that our pinky? That would kind of, okay, but they're high and fluffy cirrocumulus. Now, all of the 10 cloud types have these like 2-letter abbreviation, so I'm not going to necessarily, I don't think, hold you to that, but we are going to see these 2-letter abbreviations in the next part. Okay, cirrostratus, and I told you that cirro means the high ones, and stratus means just thin, or not necessarily thin. Stratus means flat. So here is one of the effects I was telling you that you can see around the sun. Okay, this would be actually a sun halo. It kind of looks like there's halo and corona. A halo basically looks like an angel's halo. Corona kind of comes out from the disk of the sun or the moon. Now this, if you're like me, I don't see many clouds that are kind of pink like that. This actually, to me, probably looks like a noctilucent cloud, kind of a special sort of cloud. And it's hard to tell what layer it's in. We're just going to have to trust the author that actually, or the person who posted this, that it's a middle cloud, alto, and it's layered, stratus. Okay, AS is the 2 letters for that. The other middle cloud we have is alto cumulus. And again, this would be like your thumb, or yeah, your thumb, alto cumulus. Then we have the stratus. So if somebody says it's a stratus cloud, you're like, wait, now what elevation is that, stratus? Now you didn't say alto and you didn't say cirro. So if it doesn't give an elevation, that's low. So stratus clouds are these ones right here. And one of the last slides I want to do is actually talk about fog. And fog is basically a cloud at ground level, in a sense. Then we have cumulus, and again, cumulus, I know that's fluffy, but what elevation is it? Well, yeah, they didn't say alto and they didn't say cirro or cirrus, so just cumulus must mean it's relatively low and about the size of your fist. And then I think I just skipped over this on the 10 types. This one drives me the most nuts. It's a relatively low cloud. It doesn't say alto and it doesn't say cirro. And actually, we might see these out here today. They're called stratocumulus. And if you're familiar with oxymoronic terms, you're like, well, wait a minute. That means strato means layered, and cumulus means fluffy. And I know. Stratocumulus kind of has a mixture of things going on, relatively low. Precipitating clouds, nimbostratus. Okay, abbreviation NB. And then we have our thunderstorm clouds. So thunderstorm clouds, cumulonimbus. So cumulo meaning fluffy and nimbus meaning precipitating. CB is the abbreviation for a thunderstorm cloud. Okay, so let's finish up this and then we'll go outside and take a look. So fog. So I said fog is basically a cloud at ground level. So what clouds are, remember we talked about on Monday, is clouds are basically water vapor that has condensed, water that has liquefied. That is a cloud. So kind of related to how do you get that water to liquefy here to make it fog, we have actually 4 types of fog. We have the radiation fog. And this is the one that actually you get up in the morning and you'll have this sort of fog. Basically what's happened is that the earth has cooled down. So basically you've gone ahead and it's gotten cool enough for that water vapor to condense. Remember, that was one of the things we said on Monday, that you can get condensation if you cool it down. Okay, so that's radiation fog. Advection fog, I don't see a lot of that. Advection fog would be with your large bodies of water, probably your oceans. Basically, you have a chunk of moist air kind of advecting. Advection means moving horizontally, advecting. So it moves onto land, and the conditions are right for it to go ahead and condense. Then we have upslope fog. basically, and we talked Monday about ways of lifting a chunk of air. If you can get a chunk of air to lift for whatever reason, it's going to get bigger and it's going to get cooler and it's going to condense. If you can get a chunk of air to lift. So upslope fog is kind of like that. We call that orographic lifting. So upslope fog is kind of like orographic lifting. And then the last one, actually you may have seen some of this sort of fog on the Mississippi River or actually in your showers too, but on the Mississippi River, what happens is you have that warm water that actually can have just water evaporating into maybe even cool air over the course of the night. And then again, you get condensation to happen. So I mentioned your shower. So if you've ever gotten out of the shower and seen like, okay. So what's happened is in your shower, your nice warm shower, if you're like my kids, you like really crank it up. What's happened is you've really evaporated you've created basically a saturated bathroom. Okay, so you have a lot of water vapor that's been evaporated from that heat from your warm shower, and it's condensing. So, all right. So let's go outside and see what we have. Oh, homework, but we're getting there. Okay. Oh, that felt good. All right. So yeah, one of the things about weather is I want us all to have a kind of an idea of air masses and weather fronts, and that's kind of what I put together this part for. So an air mass is a chunk of air. I kind of said a minute ago, we have an air mass coming from our west that is cool, and we have one here right now that's kind of warm. I love the warmth, but it can't stay. And a lot of times air masses will alternate, okay, and I don't know if we'll get to why that is, but they definitely do. So how big are these air masses? About the size of a large state. Now, how do air masses form? They form because a chunk of air sits over a region for a while, and it picks up what we call the characteristics of that region. So we're going to kind of break air masses up into warm and cold, okay? We're also going to break air masses up into moist and dry. So whether it's warm or cold or moist or dry depends upon where it's at. And I think it's maybe like a couple of weeks, to kind of, it's like if you go down to the South, you pick up their accent, if you're there for a couple of weeks, okay? And you bring it with you. Now, over time, that accent, if you come back here to the Midwest, that accent goes back to normal, okay? And that's kind of what chunks of air do, okay? They kind of eventually forget where they were for a couple of weeks. Okay, so we have actually what we call where they hang out, by the way, is called a source region, okay? So where they're vacationing for 2 weeks is called a source region. Now, that source region can be dry or moist, okay? And I'm going to actually come up with some air mass types that you probably heard if you're a weather junkie, you probably heard this from the meteorologist, some air mass types. So if where they hung out was dry, we could actually call that continental. Okay. If where they hung out was a large body of water, like an ocean, we call that actually maritime. Sometimes I'll call it moist or maritime, but it's a lowercase m. Okay. If where they hung out was hot, we use the capital T for tropical. If where they hung out was cold, we use the capital P for polar. What else do I have? I think that's it. Oh, there's cold and then there's very cold. Now, if you're like me, in January, February, I don't know if you remember some of the past years, they'll say, we have an Arctic air mass coming down from our north. Like, oh, drat. Okay, you know that's bad. So Arctic is even colder than polar. Okay, capital A. So I'm going to show you several source regions here in a minute for where these different air masses can kind of come in and affect us here in the Midwest, or at least North America. So actually there are 6 air masses, and I would actually only argue 5 air masses, because I'm going to show you one combination of this kind of moisture and temperature does not make sense. Okay, So hopefully you can see kind of this is Mexico down here, and this is North America, and Canada's up above. You can kind of see the outline of the continent. I've kind of grayed a few areas because I want to emphasize these different air masses. So starting with the first air mass is maritime tropical. Maritime meaning moist, ocean, okay? Tropical meaning hot. So for us here in North America, our maritime tropical air masses would be over here in the Pacific and over here in the Atlantic, okay? So those are our source regions. So if a chunk of air sits over there for a couple of weeks and then for whatever reason starts to move, okay, that's going to be a maritime tropical air mass. The next one, continental tropical. So continental tropical, now I've revealed here, continental means it's dry, it's formed over a continent. So continental tropical, lowercase c, uppercase t, tropical meaning it's still warm. So now continental tropical, actually have a note for continental tropical down here. Continental tropical air masses only form in the summertime because it's not warm enough in the wintertime to make continental tropical air masses over our North America. So they're dry and they're hot. The next one is maritime polar. So maritime meaning, again, ocean, maritime moist. Polar meaning cold, not as cold as Arctic. Okay, so we have, again, a couple of regions of maritime polar where maritime polar air masses can form over the Pacific and the Atlantic. Okay, maritime polar. Sometimes, actually, in the wintertime, it's these cold, moist airs that actually can move in and give the blizzards that we see in the Northeast. Okay. All right. Continental polar, anybody? So continental meaning dry, relatively dry, polar meaning cold. Again, polar, not as cold as Arctic. Okay. So continental polar source region would be Canada, for us. Continental polar. Okay. Then I have one more. No, I have two more. Okay. Now, maritime Arctic actually has two asterisks down here. Okay. So maritime Arctic, okay, that actually is of the six, the one that is not likely to form. So let's kind of think through why that wouldn't. Maritime meaning moist, Arctic meaning bitterly cold. Okay. Like bitterly cold and moist. Yeah, we said Monday that warm air holds more moisture than cold air. Warm air holds more moisture. So the thing about it is if you get bitterly cold air, okay, it's really not going to hold much moisture at all. Bitterly cold air. So it's not likely. Okay. Then the last real one up there, I have continental polar, or excuse me, continental Arctic. So continental Arctic. Continental meaning dry, bless you, and Arctic meaning bitterly cold. So our source region would be Greenland. Okay, so again, these are where they hang out. These air masses hang out for a couple weeks, pick up the characteristics of either moist or dry, or cold or warm, or bitterly cold. Okay, and then when they're on the move, this is what we call the air mass. This is the air mass name over here. All right. So, like I was saying, where two chunks of air intersect, two air masses intersect, we call that a weather front, where air masses collide. And if you're, not that you have to be into military to necessarily appreciate this, but you know, where two armies meet, we call that a front too. Okay. To weather. And actually, where fronts are, where two air masses are colliding, okay, you can usually expect something interesting to happen right there at their intersection, usually. Okay, so that's a weather front between two air masses. Now, what that thing is could be, like this says, wind, clouds, precipitation, severe weather, okay. Probably the most classic severe weather is like, and it's probably going to be no big deal. I'm a little bit of a weather junkie, and my adrenaline gets going when the weather gets interesting, whether it's a lot of snow or whether it's a thunderstorm. So I don't know, it's just me. But probably the most classic severe weather is when you do have a cold air mass moving in on a warm air mass. And if there's moisture with that warm air mass that's being replaced from that cold air mass, then that makes it even more interesting. So, anyway. So, let's talk about weather fronts. And I'm going to talk you through 4 weather fronts. 4 possibilities, basically, of 2 chunks of air, 2 air masses intersecting. And it's named after the air mass that's doing the pushing. So, in the case that we're describing, warm air is doing the pushing, cold air. Cold air right now is doing the pushing into warm air, okay? So actually that's why we call it a cold front, not a warm front. Warm front are usually red. I'm going to go ahead and put red there. I think these are figures from your textbook. Okay, oops, yeah, red. And they're semicircles. It's kind of nice because if you're colorblind and you're looking at a weather map to look at these fronts, you can look at the semicircles and you know it's a warm front. Semicircles. Cold fronts are blue and they are triangles. So they are blue. And that makes sense because, like, if you're blue, you're cold. If you're, I don't know. Red, you're hot. Unless you're a star, and then I guess it's kind of the opposite. Okay. Then the other 2 fronts, we have a stationary front, which is pretty exciting. Stationary front means actually you have the cold and the warm air mass they're butting up against each other, but they're not moving. So stationary front. So it's basically, I call a standoff. And I'll just kind of write on this down here. You know that we know actually the sides that the warm air is on. So actually the warm air is here and the cold air is here. And I can know that just by the direction of the arrows. I know the cold air is there because the triangles are over on this side, okay? And I know the warm air is there because the semicircles are over on this side. So even though it's a stationary front, it's not moving, we can tell the side of the air masses. The last one, actually, and you may not have heard of this one before, but it's called an occluded front. And actually, when I looked at the weather map for today with the front information, there's different weather maps. There's one with just precipitation, one with clouds, one with various things, but there's also one that a weatherman has drawn in the fronts. And we do have an occluded front right now. And usually they're purple when I've seen them. Okay, purple. And I have a whole slide to talk about an occluded front, but occluded fronts usually bring, I usually will say bad weather. If you see an occluded front. And by bad weather, I mean the wind, the precipitation, So an occluded front is formed in a nutshell. I think this is what my slides say. Basically what has happened is cold air has outrun warm air. So basically you have a couple of air masses. The cold air has outrun the warm air, kind of lifted it up like you've seen those kind of at a concert where you have people lifted up and kind of moved around. That's what I think of with an occluded front. Okay, so cold front versus a warm front. And I have a picture of both of them here. Cold front versus a warm front. Again, what we have coming through is a cold front. We know because we're going to have cold temperatures afterwards. We know it's because it's kind of warm right now. Okay, they differ by what we call the transition zones, kind of where they're meeting. I'll show you a picture of that here in a minute, and by what sort of precipitation you get with each. So, all right. Now, remember I said that we would be taking those for cloud, the 10 cloud types, actually you only have the two little letters that say what sort of cloud type that is. Okay, CU is cumulus. Okay, so basically we have cumulus clouds lifted up here, and AC is altocumulus. So if we kind of get our bearings about what this little figure is doing, okay, we have the cold air moving in. This must be warm air. And I don't know if you can tell, but sometimes I call this a snow shovel. This right here, this sort of lifting that's going on, I kind of, snow shovel, a snow plow. Because to me, it reminds me of a snow plow. Snow plows, what do? Basically, they have a nice, abrupt little shovel going along, okay, to kind of hopefully, move that snow. And the type of precipitation, actually, I'm going to put CB next to that. I'm going to add to the slide, okay, CB. And if you remember, that actually is the symbol for cumulonimbus clouds. So these are when you get cumulonimbus clouds. So the type of precipitation usually. Creating, I guess, right there. See that right there? Precipitation. So, all right. Let's compare that to a warm front. Okay, so if this is a warm front, and I wish they would have drawn this in. I'm going to go ahead and draw it in. If this is a warm front, which it is, basically we have warm air over here going that way, warm air going this way. Okay, you have cold air here. Now the thing, can you see where the warm air is trying its best, okay, to go ahead and go where the cold air is? The warm air, as it turns out, is not as dense. The warm air is light. I'm going to go ahead and put light there, as in fluffy. It's light. And because it's light, basically it doesn't scrape the ground like a snowplow would. So it's going to go forward, but basically it's going to go up and over the dense air in front of it. Okay, and it will eventually kind of scrape the bottom as it goes. But warm fronts, basically, that warm air goes, the warm air goes up and over the dense cold air. So if I put light for the warm air, I'm going to put dense for the cold air down here. And that's actually why you kind of see that transition zone. So when we say transition zone, we have a really abrupt transition zone with a cold air mass, okay, and a cold front. And we have a very sloped transition zone for a warm air mass and a warm front. So these actually, let's see, I'll go ahead and say what the precipitation is. The precipitation here is actually from nimbostratus. I can't remember, is that, well, I'll just put nimbostratus. Okay, so you're going to get precipitation, but it's not going to be your thunderclouds. Okay, the other thing is actually here, and I have a term here called, and I misspelled it on your on my notes. Maybe okay, good. It's got two N's. Overrunning. Overrunning. Basically, that's kind of what we're describing here with this warm air going up and over, nice and gentle. This is overrunning. Okay. What does that mean? It means we get these sort of layered clouds. We get the, looks like cumulostratus, altocumulus, and cirrus, kind of actually what we say in advance. So I'm going to draw a little person over here. This is my little person. Okay, he or she looks up. Okay. And what they're going to see actually is kind of a series of clouds kind of moving in with the warm front, kind of because of overrunning in advance of the precipitation, in advance of the warm air. So that is a warm front. All right. So the third one, remember, is purple. We call that an occluded front. And an occluded front, I said cold air catches up to warm air. The thing about that cold air is it's a great snow shovel. Cold air is dense, and it's also fast. Cold air is fast. So basically, cold air outruns the warm air in front of it and lifts it up, and kind of reaches kind of another pocket of cold air in front of that warm air. So basically we have 3 sectors of air. Okay, so let's look at today's, is this the last slide? Let's look at a few weather maps. Now on this slide, I'm going to go ahead and tell you some of my favorite, and y'all might have some favorites too. I hear is it WGEM out of Quincy? Or there's some great local radio or TV stations. On the internet, I like to go to, let's see, Intellicast.com. I also like to go to the Weather Channel, and that's just weather.com. That's the Weather Channel, TWC. I also like Weather Underground, so that's W for weather and then underground. Underground.com. So those are 3. All right, so let's take a look. Oops. Internet was being really slow for me, so I don't know if everybody and their dog was on it or just being slow because it wants to reboot. I think it's my laptop. Okay. You can kind of see tabs across the top. Let's check out Intellicast. And the thing about it is if you go to these different, no, let's not do that. If you go to different weather maps, they, sometimes the fronts and stuff are drawn in differently. So let's see. Now, you see the blue triangles, cold fronts, right? You see the red, that's a warm front, okay? And you see it looks pink here, but actually that purple thing right there, that actually is the occluded front right here. Okay, this is the occluded front. And then we have the warm front and the cold front. And it looks kind of like a mustache. So I told you that occluded fronts are usually kind of nasty weather. So that's the occluded front right there. Okay. Actually, it looks like we have some snow here. Have you heard that on the news? Got the snow. The green here actually is showing you rain, precipitation. Okay. Now, one of the other things, this is a good example, we'll be talking more about this, is do you see those white bars, those white lines? Okay. And they make kind of a bullseye, those white lines. Okay, right here. Actually, I could do it around the low. It's kind of a bullseye around the low. Okay, I didn't get on the lines, okay? But those actually are pressure lines, okay? Those are pressure. One of the things that if you look on the weather forecast, they will tell you what the pressure is. They usually probably say it's like 30.1 or 29.8 or something like that. That's pressure. And my point is that the closer these pressure bars are, that means every time you go to another bar, that means actually, in the case of a central low, you're going higher pressure, higher pressure, higher pressure, higher pressure. So the closer they are, that means the crazier the pressure change is. You don't have to go very far. So actually, we kind of have tight, what we call pressure gradient there. So we'll just see. So that was in telecast, no, sorry, that was Weather Underground. This is the Weather Channel, which I don't think they do quite as good. But you get a sense for another one. This one made me feel old today because I like seeing the fronts, the weather fronts, and they were like, so if you want to go to the classic, or it just made me feel old-timey. Well, I'll play around with it, and maybe Friday it will be happier. Let's see what I can do with trying to get this a little smoother. So let's go ahead and call it a day. And like I said, no homework, but I will kind of draw some questions from your textbook or some questions in general to have for you on